Welcome to the recap of episode 9. Last week we did a very nice long live coding session. Sadly, on YouTube, only 35 minutes of it is actually to be seen. And there were some internet issues during the recording, and YouTube decided to not save about an hour and 10-minute worth of it. So this summary video will be a walkthrough to everything that we did, kind of to compensate for missing all that information. What we did last time was to create user authentication, and that was quite successful, but we were left with no means to actually add new users to the system. So this week we focused on adding new users to the system, and secondly to create a new concept in a game called game, which basically persists every game session that you play and allows you to actually challenge other players to a game of trivia. So let's take a look. First change that you can see, which is most notable, is that in the UI we now have a no account, create a new one, which basically pops up a form to create an account. It does not have any advanced defenses, so all it does is say, well, you have a user account and it needs a password. If the password does not match the confirmed password, it will highlight the confirmed password. And if not all fields are filled in and these two do not match, then this button will be disabled. Once it has valid data, the confirmed password will return to its normal state and the create button is activated. In the UI or in the API, we added some new features to support this. Basically, we added a post for a sign up, which is a post to an endpoint with a JSON structure of username and password. And we added a get API/games and a post API/games. When you post something to games, it creates a new game, and you as a player are added to it. And then afterwards you are able to add friends to the game and then finally start the game itself. We did not get all the way there. We got to the point that we can create a game, add ourselves, that's it. But it's quite good progress. So in the big scheme of things, if we look at the design of the game itself, I created this nice diagram. It's not fully correct yet, but it's good enough. So we have a user with a username and a hash, and we already have the question, the answer, and the many-to-many relationship between the question and the answer. And we added this entire concept of game. So there's a game instance which has a date created, started, finished, and a many-to-many relationship between user and game. So one user can be part of many games through this link table. And then within the link table, it also has some bookkeeping regarding your progress through a game. So in that way, we can say, Arjen played Martin, and Arjen had 3 answers correctly, Martin had 4, so the winner of that game is Martin. So we can do things like that. So that's a very nice way to do it. Another good move that we made, which actually was a result of the last coding session, was that I moved the REST API out of the web server, and then after this coding session I actually took the API bits, which are specific to the game, and moved it into its own game API. So we have a web server that has a handler, a ring handler, in this case a REST API, but it could very well be a WebSocket or some other form of communication, which depends on a DB protocol implementation. Currently we have the in-memory database in Postgresql. We have the migrations that we run every single time. and the database protocol is dependent on the connection pool, and the migrations is dependent on the connection pool. So this entire stack here is our component-based system. We have some implementations for specific parts that we can switch out for testing or other needs. And we have the internals. And as you might notice, I also extracted the schema from the REST API into its own file, so the REST API can depend on it and the game API uses it. So it's turning out to be quite a well-working system. So let's take a look at the change that we needed to do. First is the view. We have a new view, of course. There are basically 3 methods that were added. Let's see if we can get it. The first one being the RDs the same, which you might feel like, and which you might be correct, is to check the password and confirm password. We have a function called all signup fields done, which basically triggers the enabled, disabled state of the button. And we have the actual form that we use, where we have 3 atoms that we use to track the field data for. And we have a basic form, which is basically the same as our login form. I'm pressing the wrong button here. Very interesting parts here are the setting of the class, most notably are the passwords the same when you input them. This is done by the function rd is the same, in which both atoms are added to it. That is checked against the not. So when these things are not the same, a has error class will be added to the element. And somewhere further down the line, about here, same thing, disabled will be set to the value of all signup fields done inverse. So when all signup fields are done, it will be set the disabled flag to false, etc. So that's pretty much it. We added a new dispatch, so a new event handler. Events, yeah. So do sign up, which is basically the button press, and there is a sign up right here. So this method is basically the event handler, the ones that we've been doing all along. And what it does an HTTP call, AJAX call to the /signup endpoint with the username and password, and it just throws all the data across. And because it also immediately creates a user session if the signup is successful, we pass the with credentials option. And that's it for the interface, really. There's not a lot to do more there. So if we go to the REST API itself and we look up all those Dutchisms, we added a post to /signup, which is basically the same thing for login, only this time it will add a user. Let's see, let's go down into it, where it is interesting. No, go away. This part right here is the call to the API to actually add the user to the database. As soon as the password enters the API endpoint, we already do the hashing, so all the further code will never have a password to its in its possession, so we cannot accidentally log it or do stuff like that. So That's fine. We create a user session as soon as it succeeds, and else we throw an internal server error. Hey, something went very wrong here. Please check it. We don't have any error handling code on the front end yet, so we need to figure something out there. But for now, it works. If we follow this path along first, the add user to the database is basically an implementation of DB protocol add user, and that goes into the Postgresql database. Add user, where are you? Let's see, add user. And add user, of course, goes into queries, which has an add user, which is right here. Add user. One of the nice things about the Hug SQL that we used is the colon less than exclamation point. It says this function will do an insert and return the ID that was generated. So as a result of doing the add, we will actually have an ID for that user to our disposal, and we can add it to the session and do stuff like that with it. For now, we don't do much with it, but it will get there. So we have that taken care of. We go back to the REST API. We introduced the two concepts of game. So the first being the post, create a game, and then the get, retrieve the list of games. The list of games currently is just an empty vector, so there's no implementation yet. But the post actually creates a user-based game. And it adds the single user to the game. So if we go into our PostgreSQL database, where are you, game users? Show the data, view all rows. Are we still connected? Yes. So you see here that my one user already has a lot of games. So the game has a unique identifier, the user is connected to it, and that means that we now have some form of history. I created several games on a day and I played them and I won or lost. We don't have it implemented yet, but I can add a new user to that game, and when they play, I can compare their scores. So that's all very nice. It works very well. If we go into the implementation of this create game, so it actually is a combination of two calls. First is the DB protocol create game, and that directly goes into the database action for creating a game, which is right here, which currently has a date started, which is automatically set to now. Right after I implemented, I pretty much figured out it's not a very good thing to do. You probably want to first have a game created or date created stamp, and then when all players are ready, you do a game started, and then you have a game finished. So, but for now, it works. Having that, having a game, and then having the ID returned from it. So we're returning the ID as we did with a user part. We take that game ID, and then we pass it along to the get game. Where are you? Get game. I made a quick boo-boo already. The create game itself, if we go to the PostgreSQL implementation, where are you? Create game, the API calls already two parts, but the create game database interaction is also two parts. The first one being create the game, and the second one add the user to the game. So what we see here is the game ID, as I already explained in the previous section, only falsely. Now it's actually true. So now db add user to the game is being called, and it adds the username, so the user entity, to the game based on the game ID, and then it returns the game ID itself. And then where are you? REST API. Let's call the API. And then for completeness, and I think we can actually wrap these into one call itself. But after the game is created and the ID is returned, we actually go back to the database and retrieve a structure that holds not only the game, but also some metadata about the game, and which in itself is an addition to the schema. So I created a new schema entity called game. It has an identifier, number of answers, number of correct. So it's a game from the perspective of the player, and it highlights the player's own reality of the game. So if I play against Martin, Martin will have different values for this part of the this part. Hello? Yeah, that was very interesting. This part of the structure, the date started, date completed would be the same as it is overall tied to the game and not to the player itself. So having done that, it did not really work at that point, but we stopped the session because it was 1 hour 44 minutes already. So then I created a helper function which actually takes the dates from the SQL entity and converts them to strings so that they can be used within the JavaScript world. Still debating if this is the right conversion. Probably it should be to Epic, but for now I want to see if it worked. I'm simply calling java.text.simpleDate format, which is actually a Java interrupt from the closure runtime to the underlying JVM and the Java language. Using this date formatter, we're now saying, well, a date will be formed to this format: year, month, date, hour, minute, second. While the actual timestamp in the database is down to the microsecond, I believe. And we do the same for date completed, but only if it's nil, it returns empty. So this is typically some code which is to be extracted, and so we don't repeat ourselves. Keep our code dry. But for now, it actually makes the entire chain work, and it sets us up for next week, where we will actually have a list of games, and we can invite players to actually challenge each other. So we should be able to actually sign up a user in 2 browsers and then actually play a game against each other. But that's for next week. We're left at a pretty good state. All the code is already on GitLab. It went through the continuous integration and the deployment. You can actually see it running on Heroku if you're interested. Is there anything else I wanted to quickly touch on? I believe not. So one thing about the live sessions, seeing the failure of having a live session on YouTube this week, I went and dove into the software that I use, the Open Broadcaster software. And I found a setting to actually save the recording of the live stream. So next time, if YouTube has is unable to process the live stream, I can upload a saved copy of it. So it should not happen again. Apologies for that. That's why this summary is a little bit longer than normal, but that's fine. I hope you liked it. If you did, like it, press the thumbs up down there somewhere. Be sure to comment if you have any questions or any remarks. Share this video, share the entire series with your friends, with your colleagues, and most importantly, if you have not done so, press the subscribe button. I might add a end screen, which allows a big button right here somewhere that you can press. Subscribe to the channel. It will keep you up to date with all the videos being posted. I hope you do so. If not, it's also fine. But please join in next Friday, 10 a.m. Central European Time for episode number 10 already. Time is flying. So have a good evening. Goodbye.